we are doing 4 using prime factorization. We are talking about what's called the GCF or the LCM today. And the first thing I want to remind you is how to do prime factorization. And I started it here, or I finished it actually, but these are called factor trees. So if I gave you the number 936, I would ask you to break it down and find its prime factors. So I chose a simple number because I know that 2 goes into 396. And I know that 2 times 468 is 936. And then you break down 468. Well, 2 times 234 is 468. Then I'd break down 234. 2 times 117 is 234. Then I would try to break down 117. And I know that 3 times 39 is 117. And then I try to break down 39, and 3 times 13 is 39. Now, the reason I stopped was because nothing besides 1 goes into 3, and nothing besides 1 goes into 13. So you can't break those numbers up. And if you notice, I highlighted what is called my prime numbers. And a prime number means that only 1 and itself go into that number. So only 1 and 2 go into 2. And only 1 and 3 go into 3. And only 1 and 13 go into 13. So those are my prime numbers. And you need to find those. Once you find your prime numbers, go ahead and write each prime number down. So if you notice, I took 1, 2, 1, 3, and 1, 13. And then I look and go, okay, I have 1, 2, 3 2s. So I'm going to make that 2 to the third power. And I have 2 3s, so I'm going to make that 3 to the second power. And I only have 1 13, so I'm going to leave it alone. And now I have broken this out, and this is my prime factorization. And you're going to use that to find your greatest common factor. So let's look at this. GCF means greatest common factor, and LCM means least common multiple. Greatest common factor means if you were looking at 72, 108, and 126, you would ask yourself, what is the smallest number that goes into, the biggest number that goes into 72, 108, and 126? The biggest number that can be divided evenly into both of those. If you know what it is, you don't have to do prime factorization. But if you're not sure, because these are pretty big numbers, you're going to have to do prime factorization. Then you have the least common multiple. That means what is the biggest number, or what is the smallest number that 72, 108, and 126 go into. So one more time. Greatest common factor is the biggest number that goes into these numbers. And the least common multiple is what is the number that these 3 numbers will go into. So we'll talk about that again if you're still confused. And you might, you're going to need to pause this right now in order to write what the GCF is and the LCM is. So because that's what we're going to talk about for this example. So once you have this written down, go ahead and listen. What I did is I gave you the numbers, and I'll scroll back up a little bit. I gave you the numbers 72, 108, and 126. And I want you to find the GCF and the LCM of these numbers. Now, if you don't know what the biggest number that goes into all 3 of these are, you would have to use prime factorization. And that's where you would use the trees, and you would find these answers right here for all 3 numbers. So I went ahead and I did the prime factorization for all 3 of them, like I did in the first example. So when you're finding the GCF, you are going to take the least power of each common prime factor. So let's find what's common. And you're looking at base numbers. Is there a base number 2 in all 3 of them? Yes, there is. So I'm going to write down a 2. Is there a 3 base number in all of them? Yes, there is. So I'm going to write it down. Now, There's not a 7 in all three of them, so I'm not going to write down 7. So the only common prime factor was 2 and 3 so far. Then you have to take the least power of the 2 and the 3. So here I have 2 to the third, here I have 2 squared, and here I have 2 to the 1. Which is the lowest power, 3, 2, or 1? Obviously the 1. Now let's look at 3. I have 3 to the second, 3 to the third, and 3 to the second. Is 2, 3, or 2 the lowest power? Obviously 2. So now you can multiply this, and you have 2 times 9, which is 18. And that means your GCF is 18. 18 is the biggest number that will go into all three of these numbers evenly. Now let's find the LCM. And remember, the LCM is the smallest number that 126, 108, and 72 will go into. So it says take the greatest power of each prime factor. So we're going to take one of each. So I have a 2, and you only write it once. If you notice, I'm not writing 2 several times. You just write it once. You have a 2, you have a 3. We already wrote a 2, we already wrote a 3, we already wrote a 2, we already wrote a 3, but we have to take a 7 because we take one of each kind. And then you have to take the greatest power. So let's look at the 2. I have a 3, I have a 2, and I have a 1. 3 is the biggest power, so I'm going to take it to the third power. Looking at my 3. I have a 2, I have a 3, and I have a 2. 3 is obviously the biggest power. Then I look at my 7. I only had one 7, so 7 to the 1 power is the biggest one I have. So I have 2 to the third, which is 8, and 3 to the third, which is 27. So I have 8 times 27 times 7 is 1,512. And that means that 1,512 is the number that, the smallest number that 72, 108, and 126 will go into. So let's do example number 1, and I only have one example because it's the same thing. We're just going to repeat this to make sure you're okay. Let's say I gave you 48 u squared v squared, and I gave you 60 u v to the third w. These are my two numbers, and I want you to A, find the GCF of them, and B, find the LCM. So you're going to look at these two numbers and go, okay, if you know what the biggest number that goes into 48 and 60 is, you don't have to do the factor tree. But if you're not sure, then you're going to have to go ahead and do the trees. So I will break it down for you. 48 is going to be 2 to the 4th times 3. Move this down a bit. And 60 is going to be 2 squared times 3 times 5. So you know with GCF, you are going to take one of every common base number. So I have a 2, and I have a 3 in both of them. Then I know that I take the smallest power. So 2 squared is the smallest over 4, and the 3 is obviously the same, so it's 3 to the 1. So I know that I'm going to have 4 times 3, which is 12. So I know that 12 is my GCF of 48 and 60. However, this time I have some variables. So the same rules apply with the variables. You take one of every common one. So I have a common u, so I'm going to write u, and it's to the second and to the 1 power. So you know it's just going to be 1 because you take the least power. I have a v in both of them, so I'm going to write v, and the smallest power between the v's is 2. I don't have a w in both of them, so I know that this is my final answer. Which makes sense for the uv squared, because u is the biggest variable that can go into u squared and u. Can't be anything else. Now let's look at LCM. LCM, if you don't know what the biggest or the smallest number that 60 and 48 go into, you would go ahead and do your factor trees. And then you would take one of every base. So I have a 2, I have a 3, and I have a 5. You take the biggest power. Well, 2 to the 4th is the biggest. I only have a 3 and I only have a 5. So when you multiply those together, you get 240. So 240 is the smallest number that 60 and 48 go into. So now I'm going to look at my u squared and my u. You take the biggest power, so I'm going to take a u squared, that's the biggest. Out of my v's, v to the 3rd is the biggest. And you have to take the w because you're taking one of each. So this is your final answer.